Okay, this is October 28th, 2024. The daily. Nope, that's yesterday's daily. I see, interesting. So what do you do, like a level order traversal? Is that fine? You do a level order traversal. I mean, I know that'll work, but like what's the simplest possible way? Is there like a DP solution? Because that would be ideal. And there is. We could do DP. DP would be pretty simple. Because you would just say like from the 9, where can you reach? Just the 11. So like if you can reach the 9, just say like, okay, from anywhere that can reach the 9, just do that plus 1. Your transition's O of 1, because from any square you can just reach the adjacent 2 squares below it or that square. And your state space is going to be, I guess, n squared. So that's not great. I guess that's the problem, is this is just like gets back to a level order traversal. Because like with a level order traversal, you're just going row by row. So you only need O of n. As opposed to DP, like you would kind of need to do O of n squared if you, let's say, did like recursively. Because you need like DFS of I and j. And then if you were smart about it and used a state machine and you said, wait a minute, like DP at I at j only ever references like ... DFS of I plus 1, j plus 1, I plus 1, j, I plus 1, and j minus 1. Like you're only ever referencing these. So like your recurrence relation is only ever relating to adjacent rows. So you only need to keep track of 2 rows. And you could just run an array through and say, this is DFS at I at all of these j's. This is DFS at I at all of these next rows j's, and so on. But at that point, you've just outlined a level order traversal. And I think, but the difference between that and like a level order traversal is a level order traversal is going to be, you would only really need to keep track of specific I and j coordinates. But the amount I've even thought about this, it's probably easier to just implement the level order. I think I can say, what's the way to do this? You can do like an import numpy and transpose in the same line. It's like import, it's like numpy dot import dot, it's something like this, I forget, but I'll deal with that later. Okay, return. So we've set t. We want to set up the q. We don't really need to keep track of the I and j coordinates. We really only need the I coordinates. So range, length, grid. Okay, and it's probably just going to be length. I'm not going to do that. I'm going to do that the fun way. Take while. So unpack this take while into a list, which is the exact same thing, pretty much as casting it to a list, but one less character. No, it's 3 less characters. Okay. So now lambda j something range length grid 0. So now we have the j. We're saying go every j. Q and it's probably going to be that plus 1. I already can kind of see that, because if you stop at the 0th row, oh, no, it's just going to be this. Or wait, what's happening here? The answer is 0. So we're measuring the number of crossings, I guess. So it's really going to be minus 1, actually. We don't really want to map to the queue. What we want to do is say map something to range of length q. So I'm saying like for the amount of elements that are in q, do this. This doesn't really matter. It's just that. Okay, now I can say x colon equals q dot pop, and I can do that safely. And then I want to look at x plus 1 and x minus 1. Or I think I really want this to be I. I don't think I use I anywhere, and this is the I. That's what I'm keeping track of here. So this is I minus 1. So I immediately want to say I and grid at j plus 1 at I minus 1 is greater than grid at I at j. Don't know why on earth I did j plus 1 there. And q dot append left I minus 1. So I'm saying there's going to be this tuple, and it's going to contain some stuff. One of the things it contains is if the right conditions are met, then I minus 1 is appended to the queue. And I'm basically just going to copy this again for the other two. That, but instead of I minus 1, it's just I. And that, but instead of I minus 1, it's I plus 1. And I didn't change the correct thing over here, and that's because I don't think I'm going to do it this way. I think what I'm going to do is say, I could just map this with and filter this, and then I can get all three of these expressions to just be one expression. So map, filter, none, range I minus 1, I plus 2. So now we're looking at these, and I want to say, get all of the values here, but I don't want none. If you input none as the predicate for the filter, it's just the identity. It's just like cast this to a Boolean and see what happens. So what I want to do is say, there's no way to say both greater than or equal to 0 and less than m without using a lambda. So that's fine. I have to do that. Okay, so now we're getting only the values that are within the bounds. And then we're going to input those, and we're going to say, for each of these, and I want an and here, and I also want to get out ahead of this because this is constantly causing pointless little errors. So we got to unpack this so that it actually calculates this map, which is fine. That's O of m space, and because it's in this it's in this anonymous function, it'll get garbage collected before the next function is called. Well, no, I don't even think I need a lambda here, because what I can do is say 0 is less than or equal to k is less than length of grid, and grid at k at j is greater than grid at I at j. Grid at k at j plus 1. And then here, all I'm really doing is just q dot append left. I'm just saying anything that makes it through this gauntlet of things that it has to have be true, just append it to the queue always. The queue could be full of stuff at the end, like there's going to be an 11 here, but I wouldn't want to do all of this for this queue because j is at the end. I'm never going to want to reference j plus 1. So I need a way to say q and j is less than n minus 1 and that. But I don't want to do this because what's going to happen is it's going to say q is 11. This will probably well, right off the bat, I don't know. The transpose is out the window. That doesn't matter anymore. I wound up doing something else. Invalid syntax. So I is q dot pop. Oh, classic. It's because right here I is q dot pop. It doesn't understand. This is like I is q dot pop and a bunch of stuff. Whereas this is like, no, I'm saying that this is all that I is. And also other stuff is true. Where do I use n? Oh, right here. Well, okay, so let's see. If I just said length of grid at 0, this probably should give the right answer for like 1. Yeah, because it's saying like, well, you didn't make it to the end, so it's fine. It's only going to have a problem if like this isn't the case. So if we change this from 11 to like 1, it should get it right now. No, it still gets it wrong. Interesting. It didn't track because when I said I colon equals q dot pop, that was evaluating to 0 when I is 0, and then the and statement doesn't go through because it's like, well, this is 0, that casts to false. That was a good one. Okay, that solves that problem. Now what's the problem here? This one's saying 1. Is it because it's evaluating to false? I also got to watch out because there's a world we're having this 11 here. Oh no, I changed it to 1. So actually that is really sketchy. Why on earth was this? So how is the answer 2? Is there anything else in here that would evaluate to false? Like this can't evaluate to false. There's multiple questions. Like why on earth is there why is it going to this third? Oh, you totally can reach the 15. So never mind. That actually is fine. But why is the length of the take while 3 when this is being output 4 times? I think it's right here. I think it's take while is like take up until something evaluates to false, and this is split on a line, so I forgot about this, but I do have sort of a naive just like when, and this was the whole point of checking this. I have a naive just like when you reach the end, just ignore the last column, I guess. But then the problem is, what if you go up through the column? So if we change this to 1, it should now be correct. Now what I was initially testing is true. So let's get it back. Let's get it back to how it was. So now all I have to do is make this be smart and not be dumb. I only want to go through with this big map object if it's not specifically at n minus 1. If it's at n minus 1, I can immediately just return true here, right? But then if I return true, it'll iterate to when j equals n, and then it'll have problems. So I want to say if it's n minus 1, return true. If it's n, return false. That would be one way to do it. So I guess I'll just say j is less than that. I mean, like, one simple thing I could do is I might be able to just have an or in here. Might be able to just say q equals length of grid at 0 minus 1 or that, depending on how like the PEMDAS works out. That's really sketchy. So it's saying if there's no q, you're fucked. If j is exactly this, then you're done. Or if it's not exactly this, then if this is the case, then you're fucked. Or if j is n, then you're fucked. And if j is not n, if it's less than n, then you can do this. All right. Well, let's see how it does, I guess. Uh-oh. And why is it wrong? I might not need this at all. I think that's going to cause a lot of problems, though. Yeah. I need to make sure that the length is this and the queue has anything in it. Then it's legit. Oh my god. But I put this first because specifically it's the only thing that really needs to be OR'd. I mean, I guess like a quick thing, and I'm getting pretty tired. I could just say queue and anything here. Take while to there. So it's going to be q and either j's length of grid is 0 minus 1 or all this other bullshit. Let's get these print statements out of here. Oh my god. Oh my god, what a nightmare. Good fucking lord.